Hey class, I wanted to go over this problem a little bit because some of you had, quite a few of you actually had an issue with this proof, and the direction that seemed to be causing the most trouble was actually the forward direction. That is to say, this direction right here. And so I'm going to go ahead and do a version of this proof. There's many of them that are correct, and a lot of you had really good ones, but there was one issue that I kept seeing over and over, and I want to make sure I address it. So here we're going to assume, so we're going to suppose that a is less, that the absolute value of a is less than or equal to k. And then here's sort of the mistake that I saw. So I'm going to do this in a different color so that you guys know that it's wrong. But you said there's two cases. A lot of you said that there was two cases. So case one, suppose a is positive, greater than or equal to 0. Then you said, well, this means, so by definition, and this is correct so far, by definition, the absolute value of a must be equal to a. And by assumption, it's greater than k. So we've got, I'm sorry, I'm not paying attention to what I'm saying. By assumption, we have that it's less than or equal to k. And so we got something. We got this right-hand side. So you're like, okay, good. And then you said case 2. Well, now suppose a is less than 0. So by definition, the absolute value of a is the opposite of a, so negative a. Well, I would rather say the opposite. And of course, we know by assumption, which is less than or equal to k, that this implies that a is greater than or equal to negative k. And now we were happy. A lot of you were happy because, oh, there I got the other one, and I'm done. But there's a sort of a problem with this, and the issue here is that you're saying that in order to get this conclusion, we have to assume that case 1 and case 2 are true. And if case 1 and case 2 are true, so in order for it to work, according to the logic that most of you use, so that means that a has to be greater than or equal to 0 and a has to be less than 0. But this just means that a must be 0, and that kind of goes against what I asked you to assume. I asked you to assume that a had to be any real number. And so there's an error in logic there, that you thought that these two cases proved a full case. And so the way the logic goes on this one is that, and so I'll do this in blue to kind of correct what we have to correct. When you assume that a is greater than or equal to 0, you should be able to prove the conclusion. So we need a little bit more work here. It's not enough. We can't stop right here. And we have enough. Because of the following. You guys know by assumption, by case 1, that a is greater than 0. So let me say, note, a is greater than or equal to 0, and negative k is less than 0. So in other words, a is non-negative, negative k is negative. Thus, that means that a must be greater than or equal to negative k. And there it is. A is less than or equal to k, a is greater than or equal to k, therefore negative k is less than or equal to a, and it's less than or equal to k, which is what you wanted. So just by assuming, so again, this has to be for any real number. So the two cases we should consider if a is positive. If a is positive or greater than or equal to 0, then I should be able to come up with this conclusion. I didn't need to use both cases. In one case, I should do it. And the same thing here with the second case. A is greater than or equal to negative k. Great, we got part of it. Now, using this, I should be able to show that a is less than or equal to k. And again, this is sort of not that bad. So here I want you to note that our assumption says that a is negative, and our assumption says that k is positive. Thus, a must be less than or equal to k, just like that. Hence, negative k is less than or equal to a is less than or equal to k. And there you have it. Now that a is negative, I was able to show that if I assume that the absolute value of a is less than or equal to k, then I've got exactly what I need. And so this is the proof that I was expecting you to be able to do, because the other way the logic just doesn't make sense. And so if you have any questions, feel free to come in the office or send me an email or just talk about it after class. Right, so I hope this helps with this proof. Actually, there was another mistake on 1b that a lot of you made, so I'm going to go over it in a separate video. So, thanks a lot.